We've covered integrated assessment models, the social cost of carbon. Now, how do we use them? That's what this lecture is designed to answer. Global climate change policy. What are these integrated assessment models good for? Where do we go from here? You will estimate the social cost of carbon. You've already done this in one of your assignments, but you'll do it again for the final group project in your paper. And then what do you do with it once you've estimated it? Do you ignore it and rely on naturally occurring emissions reductions? In other words, the sigma parameter in the model. Do you hope that that CO2 per GDP parameter is going to decrease over time naturally and just let emissions decrease at their own rate? Will they? We don't know. Or do you create policies to mitigate or adapt? And the second, of course, is the one I want to focus on, and then the one I want you to write your paper on. So for the first, we have something called the environmental Kuznets curve. It's the potential for naturally occurring emissions reduction. So the idea is that on the x-axis here we have income per capita, or basically economic growth. And as countries get, and on the y-axis we have pollution, environmental degradation. And historically, these two things have been positively correlated. So in order to grow our economies, we had to pollute the environment. We had to hurt the environment. And the idea here is that at some point, we turn that around. We become cleaner as our income grows. So if we bring up the average income in the United States, potentially we will see environmental degradation going down. And hopefully that happens all over the world. It's kind of the Star Trek great outcomes for society scenario. As an example, we might have Pittsburgh around the turn of the century, or Britain, when in order to industrialize, they polluted a lot. They used coal for all their manufacturing and electricity production, which basically made the cities really, really polluted, a lot like you see China and India today, except much, much worse. When people were dying from lung infections, the black lung, just from having coal in their house, burning coal in their house. And now you see Pittsburgh today. That's obviously an enhanced picture of it, but the idea is that they've cleaned up the atmosphere and there's less environmental degradation. We've even in the United States we've polluted rivers so bad that we've been able to light them on fire in the past. Is there actual evidence for the environmental Kuznets curve? Well, we see GDP per capita increasing over time steadily. This is really, we haven't seen any decline in that, but at the same time, we have U.S. per capita carbon emissions from energy consumption from 1960 to 2012. You can see that this is the sigma parameter. That's been going up in the United States, or it was going up in the United States. It kind of leveled off, and it seems to be declining. So the question is, will it continue to decline? And if it continues to decline in the U.S., what is it going to do in other countries? How about China and India? Will Chinese emissions decrease as GDP grows? China's emissions are fairly high right now. Do we expect them to decrease as their income grows? Probably, but will China, India, and Africa, other developing countries, will they do irreparable damage to the global climate on the way up? And that's not to say that China and India and Africa would be to blame, because other countries around the world have done their fair share of damage as well. Here are the emissions trends from developing and developed countries alike. You can see the developed emissions from production and consumption have been fairly stable since 1990. But the developing country emissions have been increasing. So that's the question we need to answer. Are those emissions going to continue to increase, or will they kind of leapfrog the industrialization process and start producing all their energy from renewable sources, kind of jump over the damaging portion? Alternatively, we have global climate agreements and domestic climate policies. So that was, we would rely on naturally occurring emissions reductions to solve our problems. Here we're going to say, let's impose some global climate agreements and policies. So what's the history of global climate agreements? This started back in 1992 in Rio, where the UN Framework for Convention on Climate Change was established. It was 154 signatories to the UNFCCC. They agreed to stabilize greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous interference with the climate system. The US signed this one, and so they've been working on this at a global scale since 1992, fairly long. 1993 to 1996, negotiations. 1997, the Kyoto Protocol, which led to legally binding emissions targets for developed countries. For the 6 major greenhouse gas emissions, it never passed Congress, though, in the United States, so we didn't do anything about it. More negotiations. In 2015, we had the Paris Agreement. The Paris goals would keep temperatures increases below 2 degrees C. Most climate models show a doubling of greenhouse gas emissions from pre-industrial levels. Those were roughly 260 parts per million. A billion parts per million will result in warming by between 2 to 5 degrees centigrade. What does that mean? Two degrees centigrade doesn't sound like a lot, but an increase in average temperatures of 5 degrees C is equivalent to the difference between the Ice Age temperatures and today. So 5 degrees cooler could lead to most of the United States being covered in a mile of ice, or some depth of ice. I'm not entirely sure how deep it was. It established binding commitments to make nationally determined contributions. Okay, so they're binding, but they're essentially voluntary. All countries, and are they actually, what does binding mean? You could fudge that and make it so you say you're going to do something, but you don't actually intend to do anything. All countries needed to report regularly on their emissions, and developed countries were to support the efforts of developing countries through transfer payments and transfers of technology. The idea is that developed countries like the US and Western Europe, we did our polluting. We're still polluting a lot. We're polluting more than most countries, but we did the majority of our polluting on our way up towards industrialization. And now we're trying to reduce our emissions. Is it fair then to say to other developing countries that they cannot produce emissions in order to increase their economic well-being? Well, of course not, but can we help them increase their economic well-being through cleaner methods than we used? And the idea is that we would transfer technologies and payments to developing countries in order to allow them to develop electricity infrastructure, but do so without producing electricity with coal and natural gas, etc. Basically, build electricity infrastructure, transportation infrastructure that depends on renewable electricity and maybe electric vehicles. So that's called leapfrogging. Are we on track to the 2 degree C target? Not even close. This figure, you can go to the Earth CO2 homepage and see what the atmospheric concentrations of CO2 are. In February of 2018, they were 408. Today, I looked it up. I think it was 414. So we're steadily increasing. Yeah, we're not on track. Countries that joined the Paris Climate Agreement. let's see, countries that, easier to focus on countries that didn't join: the United States, Nicaragua, and Syria. Incidentally, Nicaragua didn't join because they didn't think it was strong enough. So they were joining out of protest that the Paris Agreement didn't go far enough. So basically, the United States and Syria stand alone. We're the only country that doesn't believe, that a majority of our politicians don't believe in climate change. Okay, but what if we could suppose the Paris Agreement was signed? What policy should be chosen? We went through this before. Should we choose prices or quantities? We could have a global tax on carbon. We have a lot of experience with international taxes in terms of tariffs or trade agreements. None in the environmental realm, though, so this would be new. Global quantities, we could have regional emissions limits. Not as much experience with these, except with CFCs, and difficult to adjust as economies change. So again, we're going to be back to tax or not to tax. We're going to be back to taxes as the most efficient mechanism for addressing global emissions. In 2007, Nordhaus, of course, asked this question. Nordhaus preferred harmonized carbon taxes, meaning harmonized across all countries in the world. So this would be the same carbon tax in all countries. We'd give exemptions to poor countries. Avoids the difficulty of setting and adjusting quantity targets to different conditions. It'd be very difficult to set quantities for every country and then to monitor their emissions output and make sure that they're adhering to their quantities. It avoids volatility of market prices. So if we had even if we implemented a cap and trade program where countries could trade permits for emissions, we'd still have pretty volatile emissions permit prices. Why? Because we don't know the elasticity of the marginal abatement cost curve, and there's speculation. Also, the quantities that countries produce are dynamic. So if you set a binding cap on emissions for emissions outputs today, but then the economy declines like we're in right now, and so emissions decline, then the cap is no longer binding, so emissions permit prices drop to zero. But then as soon as the economy recovers, they start producing emissions again. The cap maybe becomes binding, and emissions prices spike. It's easier to use tax revenue to reduce other taxes than auction revenue. So another thing we could do is we could take the tax revenue from carbon emissions tax and use it as the transfer payment to developing countries. So when we talked on the previous slide about how we could help other countries leapfrog, we could use the tax revenue from a globally harmonized carbon tax to as a transfer payment to developing countries. That's called the double dividend. Why is regulating greenhouse gases so complicated? Why have we failed at a global scale? Well, climate change is a public goods problem. The conditions of public goods are that they're non-rival. The consumption of the good by one individual does not inhibit another's benefit from the good. If I breathe the clean air, it doesn't stop others from breathing clean air. It's non-excludable. I can't stop someone from enjoying the benefit of the public good, even if they haven't contributed to it. So if I use renewable energy, which reduces pollution, it costs me more, but others also benefit from the reduced pollution. So typically I play a public goods game here in class. The takeaway from the game, which is kind of neat, is that public goods are contributed to with only two groups. So if I split the class in half and pretend that half the class is one country and the other half of the class is another country. And then we see who contributes to reducing climate change, the public good. And with only two countries, then we get full cooperation usually. Because you kind of trust the other half of the class. There's only one other entity to trust. You both benefit. It's a fairly easy problem to solve. But as we add more countries, as I split the class up even more, the contribution rate declines dramatically. So going from 2 countries to 4 countries, the contribution rate might cut in half. And by 6 to 7 countries or 6 to 7 groups of students, the contribution rate declines basically to 0%. And this is a very common output of game theory, the public goods game theory models, that the more entities you have contributing to a public goods problem, the less contribution you have to the public good. And so that's the situation we're in. We're in a situation with many different countries trying to deal with a gigantic public goods problem. So we have very low participation. How can we get to the everyone contributes solution? Of course, that begs the question. What can we change to get to the everyone contributes solution? Of course, Nordhaus has an answer for this. He calls it climate clubs. Is it an answer to international climate policy? We'll see. His answer is we need to make the benefits excludable. And he calls this a climate club. The conditions for the climate clubs are as follows. There's a public good type resource that can be shared. The cooperative arrangement is beneficial, including dues, is beneficial to each member. The members can be excluded or penalized at relatively low cost to the members, so we need to exclude countries from this membership. And the membership is stable in the sense that no one wants to leave. The pictures on the bottom are Nordhaus when he's young, Nordhaus when he's old, and Nordhaus's dog. Nordhaus's climate clubs have 2 rules. Member countries must put a price on carbon domestically. They must have this harmonized carbon tax. And this could be implemented through a carbon tax, a cap and trade system, or in another mechanism. Of course, he prefers the carbon tax. And the member countries must also agree to impose sanctions on non-member countries. For example, tax imported goods from non-member countries. And this creates an incentive for non-member countries to join the club. Okay, how does this work? Suppose we have a North American club, Mexico, the United States, and Canada. And our club says that we all put a tax on carbon emissions. Okay, we do this, nothing changes except we have this tax on carbon emissions. But if some country, the United States, decides that we don't want to impose this tax on our emissions, then the other countries, Mexico and Canada, penalize us. And they penalize us by imposing sanctions on us. They put tariffs on our imported goods, and basically they're shutting down trade with us. So it's going to hurt their economies, but the idea is it's going to hurt the U.S. economy more than it hurts them. And so if it hurts the U.S. economy enough, then the U.S. is going to decide it's worth implementing the carbon tax in order to not pay the tariffs on or deal with the sanctions on trade between Mexico and Canada. And if we expand this to other countries, then you can see maybe it could have an effect. Nordhaus uses the Rice model to test out his theory of climate clubs. The Rice model is the regional dice model. It aggregates countries into 15 regions of the world. And so these 15 regions are going to be the clubs. The question is, what tariff or tax on imports would be necessary to incentivize most all regions to join? The model weighs the costs and benefits of joining for each region to determine who should join. Countries maximize social welfare considering costs of abatements, costs of trade sanctions, and costs of climate change damages. It's harder to get countries to join with higher carbon prices, even with increasing tariffs, and this is because tariffs increase linearly, but abatement costs rise non-linearly. So, the carbon prices, as the carbon prices rise, you have more incentive to not join, and it's harder to get countries to join, even with increasing tariffs, because the tariffs rise linearly, but the abatement costs, or with the carbon price increasing, you have to abate more, and those abatement costs increase faster than the tariffs increase. Here's a graph from this Climate Club's paper, how many regions participate at different carbon prices and different tariffs. Here's how you read this graph. The x-axis is different carbon prices, dollars per ton of CO2. So the first block of colored lines is a $12.50 carbon tax. The second block of colored lines is a $25 carbon tax. Then you have a $50 carbon tax and the $100 carbon tax. And each of the colored lines is the tariff rates. So each of these blocks has 10, you should have 10 lines. So starting from 0% all the way up to 10%. So there should be 11 lines actually. And then on the y-axis, we have the number of participating regions. Now, how do we read this? All right, the first line that I've pointed to here in blue is 0% tariff with a $12.50 carbon tax. This is the current situation. We have 0% tariffs. In other words, there's no trade barriers, no clubs at all. So there's basically no reason for countries to participate in the public good in the global climate policy. There's no reason for them to implement the $12.50 tax. So this is the voluntary provision problem. And what this says is that we have 0 participating regions when there's no tariffs. But with a $12.50 tax, all we need is a 1% tariff, and his model suggests that we get all countries participating, or all regions participating and implementing the tax. And so at 1%, 2%, 3%, all the way up to 10% tariffs, we get all countries participating with a $12.50 tax. Now let's go to 25%. Again, with a 0% tariff, that's the little non-existent bar at the very left of the $25 target price. We have 0 countries or 0 regions participating. But as soon as we implement a 1% tariff, we get up to 9 regions participating. That's pretty good. A 2% tariff gets us up to 13 regions participating, and then a 3% tariff gets us all the way up to all regions participating. At $50 per ton, let's look at maybe 2% tariff, we get 3 regions participating. A 4% tariff, we get 7 regions participating. 5% tariff, we get 9. And 9 and 10% tariff, we'll get 14 regions participating. So we don't get full participation. There's at least one region that doesn't participate with a $50 per ton. But that's pretty good. So 9% tariff on non-participating regions gets us nearly to full participation with a $50 tax. With a $100 tax, all the way up to 10% tariffs, we can't get close to full participation. We only get 6 regions participating. So a $100 tax is going to be hard to get global participation. Here are the net benefits by region from the Rice model relative to the non-cooperative outcome, or basically the outcome we're in right now. You can see that the EU has the highest net benefits. A lot of places have fairly low net benefits, India in particular. The differences depend on the carbon intensity of production and the trade openness that they already have. So if a country has high carbon intensity production, they're going to be hurt more by the social cost of carbon, places like India and China. And their trade openness, places like Russia, maybe they aren't going to really benefit or be hurt by the tariff. Asia tends to lose because of high carbon intensive production. Tax will cost them a lot, or they invest in expensive abatement. So if you try to tax the carbon emissions from India and China, they're hurt a lot, or they have to figure out how to completely change their energy infrastructure. Will climate clubs work? Maybe pause the video and think about this for a moment. What could be the problems with this? One limitation is, what if non-participant countries form their own coalition to engage in a trade war? Could the equilibrium go the other direction? So that's a worry that some people have, is that there's a bunch of countries that decide they want to go against this, and they form their own coalition, and they impose tariffs on the participating countries. The bottom line on climate policy and integrated assessment models. The energy sector is the largest producer of emissions. That's why we've been studying this in the first place. The global climate policy has failed to address the emissions because climate change is the mother of all public goods problems. And as we would have seen by playing a public goods game, that more countries or more participants leads to lower contributions to the public goods. And we also could have simulated the climate clubs thing in a public goods game and shown that climate clubs can work. The most efficient method for addressing emissions is a global carbon tax, with some caveats for certain countries. We would also need a lot of additional side policies for distributing tax revenue and aid. Integrated assessment models produce lower bound estimates on the social cost of carbon, which is, this is the main thing I want you to get out of this. The social cost of carbon is an estimate of the optimal tax on carbon. So if we draw that welfare graph with the private marginal cost sloping upward and then the social marginal cost bumped up from that, the difference between those two is the externality cost, which if you put a tax on that externality cost equal to that externality cost, it'd be called the Pigouvian tax if you take an environmental economics. These things get us an estimate of the Pigouvian tax, or the optimal tax. So in integrated assessment models, this whole exercise that you're doing is designed to produce an estimate of the optimal tax on emissions. That is the social cost of carbon. It is the optimal tax on emissions. Policymakers could take these estimates and set a carbon tax. Then you think about in your paper, what is that going to do to the economy, to different sectors, to energy production, transportation, etc. Will we ever address climate change globally? I don't know. One possible fix is climate clubs. Questions for you. What is your perspective on integrated assessment models at this point? Potentially after you've written your group project and your paper. And what is your perspective on the social cost of carbon? Do you believe it? Should it be used in policymaking? Questions specific to the DICE model. Which model is most uncertain? Which module is most uncertain out of the boxes to the right? The production function, the emissions, the atmospheric concentrations, climate sensitivity, the temperature rises and global climate change, the damages, or the welfare function. And what would you still like to see? How do you think it could be improved? What do you think is the most important part of this? The answer to that question, according to people doing research on the topic, is the most important parameter in the DICE model is the discount rate. So if you've chosen the discount rate group, you've got the most important parameter in the model.